Hey, what's happening, guys? We're back talking about my synthesizer experiments again. And once again, I have no experience with this, so these are only experiments of my doing. But you're welcome to follow along if you like. So, in our first video, we used the simple 555 timer circuit to generate a frequency. And I said, we're not going to do that. So my plan was to use a hex inverter like this HC74HC04. And what you can do with the hex inverter is simply connect an input to an output. And that should produce an oscillation because, all right, let's look at it. Pin 1 is the input, pin 2 is the output. So right now, there's nothing going in. So there's a 0 going in, there's a 1 going out. So if we take our 1 going out and we connect it to in, so our 1 goes out, and it now goes in, and what comes out is a 0. So the 0 goes out, the 0 goes in, and the 1 comes out. So it should oscillate, and then we could put an RC circuit on there to control the frequency, but she ain't working. I pissed around with it. I think this chip is kaput, and frankly, it's the only hex inverter I have in stock right now. So we got to do something different. There's 1,000 ways that we can make an oscillator. Transistor oscillators. Yeah, there's way too many to get into. Let's keep it simple, right? KISS. Keep it simple, stupid. What's probably the easiest thing I could think of? An Arduino and the tone command. So, what I've got here is just a nano. I got a pot, doesn't matter the value, connected up to A0. Vary the pot, we vary the frequency using the tone command. Now, if we roll up here and look at the scope, let me zoom in here so you guys can get a better view. You see we've got a frequency of about 322 hertz. So if I vary this potentiometer here, turning it one way all the way, we get to like 378 hertz. Turning it the other way all the way, we're down to 261 hertz. 261.23, I believe. 261.63 is C4. So that's the bottom of our scale. I've just rigged this to go from C4 to B4. All right, so we'll come back down to our Arduino here. And let me move something. Hold on. I just had to move the power cord around. So now we have our Arduino as an oscillator. And you can see the square wave there on the screen. Now somewhere around here, here we go, had a set of jumper cables. So let's attach them to the output. And then I'm going to attach this to the speaker. And don't worry, they're not going to be the shrill sounds. These are going to be some pretty mellow sounds. Alright, so I'll attach the ground first. That way, my external computer speaker system and the Arduino and the oscilloscope are all at the same potential. Alright, can you guys hear that? And you can see it. So what I'm going to do is adjust the frequency by turning this pot. So there you see we have about 1 octave. All right, so we have our oscillator. Great. Next thing I want to do is put in a filter. So let me gather the components and we'll get to that next. Okay, so I grabbed my we're going to start with my lowest value capacitor. It's 0.1 microfarad. And we're going to use 2 legs of a potentiometer as a variable resistor. So I'm just going to disconnect the scope for the moment. And I'm going to connect the ground up down here. And we will take our output from the Arduino and bring it over and put it in one side of the resistor. Then we just need another wire on the outside, like that. And we just need a place to hook up our ground for the scope. And then we can hook up that. So, what have we created here? Well, if you follow the function, build your own function generator video, we've got an integrator on here now, which is also a low-pass filter. And you can see the effect that it's having on our waveform here. Oh, look at that. What have we created there? Well, that's a pretty sawtooth wave. Let's hook up our jumper wires to the speaker system. Always hooking up that ground first so everything's at the same potential. And then we'll hook up this output. Okay, can you guys hear the sound? There's our sawtooth. Zoom all the way out here. Now I'm going to adjust the filter. See how it's attenuated that signal? Now it's almost completely gone. Only the lowest frequencies are passing through. Let's set our trigger at 50% so we get a solid reading. Very nice. So we've taken our square wave and we've made it into a sawtooth wave with a low pass filter. And with that, we can control the timbre of the sound. Now, let's try changing capacitor value. That was 0.1. Let's go up to, how about 0.33? Let's see what that does. Okay. I don't know if you guys can still hear the sound, but it is a much mellower sound now. I actually like it. Okay, so there we have a very near square wave, and it's rather harsh. And then by adjusting that, we can mellow it out. That's pretty cool. All right, I'm going to take the sound off of here, because nobody wants to listen to that all night long. All right, I think this is going to be the basis for our synthesizer. Although, I want to have more than one operator. We'll worry about that later. So, we have our Arduino just outputting a tone. We can control the frequency with this potentiometer, and we can control some of the envelope with this low-pass filter. Now, in our next experiment, we're going to add to this a high-pass filter, and that will allow us to massage the sound even more. And I think that's going to do it for today. So I hope you guys enjoyed this. Remember, I'm just experimenting here, and I may screw stuff up. But if you enjoyed it, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. A big thanks to all my patrons. That's it. I'm out. Peace.